Welcome to General Structures 2 and Lateral Forces, Lesson 5, example number 10. And it says, for the parapet wall in example number 9, what is the moment at the corner of the building? Alright, so this time I'm not going to do everything over again. When you're looking at this, the only thing that's going to change, if you look at the equation, and that's what I would tell you to do. Equation is P equals CE, CQ, QS, and I. Right, so this is the same one as at 9, so that was the fire department in LA, which is 15 foot tall, has parapets. So the importance factor, let's just cross out what is the same. Meaning it's not going to change. This is not going to change because it's based on the importance factor, which it's still an important building, which is a fire station. Because if you have a horrible windstorm, the fire station is the one thing you want open, so the fire department can get their firefighters to go help other people. So that's why the importance factor is 1.15, but that's not going to change, so we can cross that off. Over here, QS, it's still in Los Angeles, it's going to be the same, so let's cross that off. That's not going to be different. Your exposure factor, this is going to be in the same place. This is the if it's next to an ocean or in the middle of a city or like in the middle of a desert or middle of a flat plain, this is not going to change. It's still in LA, in the middle of LA, so you're going to have the same 0.62 exposure factor. And right here, this is the pressure coefficient. Right here, pressure coefficient. And if you'll remember, last time we used 1.3 in example number 9 because it is a parapet wall. It was 1.3 inward or outward. Pressure coefficient. This is the one thing that changed. Now we're talking about a parapet wall, but in the corner. In that case, you go to table 16H. So let's take a look at what our options are. So you look up at the top, it says elements and components not in areas of discontinuity. And this is actually going to be an area of discontinuity, so let's go down to 3. It says elements and components in areas of discontinuities. And that's what we want. And as you can see, the first option under description is wall corners, and that's exactly what we're talking about. And it says 1.5 outward or 1.2 inward. And let's look, I mean, obviously this would control, unless you have to do inward. So let's look at what it was asking. It says, what is the moment at the corner of the building? So, let's go ahead and do the outward one, because the way we were looking at it before is I was looking at it like a cantilever beam coming up, and this equals this. And that's, once again, that's up for discussion how you would like to look at this, but you can look at it many different ways, and you could justify it many different ways. So we're looking at it like this. That would be inward, but let's go ahead and make it outward. So let's get rid of that. Let's use green. Very Christmas festive. Even though it's past Christmas now, on my time. I have no idea when you're actually going to be watching this video. Anyways, here you go. And this is going to be that P. And this, we're going to use the 1.5. Since it's larger, it will control. So, if you remember correctly, it was what? On example 9, was 11.7 PSF, and to get, and we were using a 1.3, so let's divide by 1.3, and now we're going to multiply by our 1.5, and we're going to get so let's take 11.7 times, or let's divide it by first. Divided by 1.3 times 1.5, and we should get 13.5 PSF. 13.5 PSF, there we go. And if you remember, we can just do this in our moment, And you can go to your steelbook has these equations if you don't trust me, but this is actually going to be your line load on a cantilever times WL squared over 2, I believe. I'll tell you what, I'll even go to where I have that in my steel book just to double check that I'm not messing up the equation off of the top of my head, because I was doing that. It seems to make sense. And if you go to a steel book, they have these beam diagrams and formulas where it tells you all these things, so you can double check. And I'm looking at number 12, which is beam fixed at one end, supported at other. No, that's not the right one. Scratch that. We want a cantilever. Oh, there we go. Number 19, cantilever beam, uniformly distributed load. So that's what we're looking at. It's a cantilever beam. It's a uniformly distributed load. And we want to go to M max, and it says at fixed end, and that's what we want. WL squared over 3. WL squared over 3. And I said 2. Why did I say 2? Oh, I'm looking at the wrong one. That's why it's WL squared over 3. It's over 2. I was looking at 20. And that's with a moment added to it, I guess. Anyways, it's WL squared over 2. And if you want to justify that to yourself, you take W, because this is W. W equals your uniform distributed load. And you're taking that times L to get your equivalent load. And then you're taking that times half. Remember, because we took 2. Anyways, you can justify, and I like justifying these to myself. I think it's a good, because then you trust the equation. You just don't take it as word. So let's go ahead and solve PSF, 13.5 PSF, which is W once again. And that you can really look at that as PSF per foot. Per foot. You can say that right now, but it might confuse you, so I won't. And then times L, which is 4 foot, squared over 2. So 13.5 times 4 squared divided by 2 equals 108 foot pounds per foot. Okay, let's double check to make sure we got the same thing that they did in the study guide, and they did. 108. And they just say foot-pounds. But once again, I want to emphasize that it's 108 foot-pounds per every foot. So if you, this is you're taking, here's the parapet sticking up. Here's the corner. Let me think, how would I draw that? That'd be fine like that. There's your corner. And, you know, at what point do they say, oh, this is the corner, and how far does the corner go out? And I'm sure they have some guidance on that as well. But as far as that goes, you know, let's say it's 3 foot or 4 foot or whatever the code will say, you have to divide that per foot basis. So that's 108 foot-pounds per foot. So if you have to look at it as a, you know, this is 1 foot. So this is 108 foot-pounds, and this next one is 108 foot-pounds. So I don't want you to think that. So if you design that in concrete, you need to design it on a foot basis, because if you design this, you know, let's say it's 3 foot wide, and you say it was only 108 foot-pounds, then you'll put less steel in there than you need to, or you make it the parapet wall less thick. Usually it won't be a concrete parapet wall. I don't think that's ever going to be, or typically won't be the case. I won't say ever, because that's not something I like getting in a habit of doing. But you get my point. You need to know that that's per this foot piece, that swath of foot piece. That moment right there is going to be 108 foot-pounds per foot. Okay, I've beaten that like a dead horse, so I will see you on the next example.